Welcome, students. We are in Algebra 2, Lesson 72. This is a review of your pod for Monday. So since we're not going to be able to meet on Thursday because it's a snow day, Miss Anna and I decided to be okay to do a video review as if you were in class. So if you have these problems correct, you do not have to watch the video. You can just fast forward to the ones that you need, skip the ones you got right, and that will help you with those problems that you struggled with, help you get there, just as if you were in class and we were explaining it to you in person. So there is that. So let's look at Lesson 72. We only had 4 problems, but they were all doozies. They were hard. So let's look at number 1. We were supposed to write the equation that gives hydrogen as a function of carbon. So hydrogen as a function of carbon, so that would be, slope carbon plus B. That would be the formula for this one right here. So hydrogen is a function of carbon. Oh, well, I guess it helps that it's already written out there for you. I didn't know I was so kind. Look at that. So we're going to use these points here to find our slope, and then we're going to sub in one of the points in order to find the positive or the B point, the y-intercept point. So to find slope, we're going to do change in y over change in x. I'm just going to do it in order that it's written, 80 minus 130 over 100 minus 106, and 80 minus 30, that's going to be a negative 50 over a negative 6, and is that right? Yes, that's right. So that's obviously going to be a positive because it's a negative and negative, and 50 over 6, we can reduce that to 25 over 3. And it's now a positive number. Now, typically in scientific work, you're going to do the decimal. You're not going to leave it in a fraction. So we'll do 50 divided by 6. It should be the same thing as 25 divided by 3, 8.333. So yeah, should be the same thing, 25 divided by 3. Yeah. So it would be 8.3 with this little thing over the top. That's your slope. So we can already start to rewrite it as h is equal to 8.33 c plus b. So we got to find that plus b first. So let's sub in hydrogen and carbon. Remember, hydrogen is the y, so it's going to be, I'm going to use the first point, 80 is equal to 8.33 times 100 plus b. So that's going to be 80 is equal to 833. And we'll just forget about that little rounding thingy, plus b. If I subtract 833 from both sides, 80 minus 833 is 753. So negative 753 is equal to b. So I can rewrite that as h is equal to 8.33 c minus 753. And that should be correct. I do want to point out, whenever you write this in your system in Jupyter, you're not going to be able to do that little number right there. So just do 8.33 and leave it, and we'll move on. But this is correct. This is the right answer. Let me get this up. There we go. Let's move on to the next one. We're going to do the exact same thing. We are going to find the slope, which is going to be 1 minus 10 over 40 minus 160. So it's going to be negative 9 over negative 120, which is going to give us a positive value. Let's put that in the calculator. And we're going to say 9 divided by 120. That's going to give us 0.075 5. So 0.075 is our slope. So we can already start to rewrite that as S is equal to 0.075 C. I'm going to come over here and I'm going to use that. S is equal to 0.075 C plus B, and sub in this point because it's a smaller number. This is my Y, and this is my X, 40 plus B. So I'm going to multiply that by 40. That gives me 3. So 1 is equal to 3 plus B. Subtract 3 from both sides. It gives me a negative 2 is the value of B. So I can put my negative 2 right there, and that should be the correct answer. And it is. I'm checking the system. Oops, that's not what I meant to do. As I go through here, just to make sure that what I'm telling you is correct in the system. I don't want to give you something to type in and it's not right. So now we're going to express or write this polar coordinate in rectangular coordinates. But first, I've got to let Roscoe out of the craft room. Hang on. All right, he was making racket. He needed to be let out. So let's look at this one. We have a negative degree here. So that means we're going to measure from the x-axis in a clockwise or down and around rotation. Instead of up and around, it's going to be down and around. So clockwise from the positive x-axis. So that's going to tell us where it lives in regards to the Cartesian coordinate system. So I'm just going to make a little system right here. And I'm going to make a little T90 measurement. I know that from here to here would be negative 90. From here to here would be negative 180. And then from here to here would be negative 270. So negative 230 is going to be in here. So 230 minus 180 is going to be 50 degrees. So that means that this angle here is going to be 50 degrees right there. And I'm going to be in the negative R, positive U position with my negative 230, and my hypotenuse has a length of 5 or a magnitude of 5. All right, so there is where I'm at. So now what I'm going to do is I'm going to say 5 times the cosine of 50 degrees is equal to my negative R. Let's go ahead and do that one. So 50 cosine times 5 is 3.21. This 3 does not round up, so we're going to stop right there. So 3.21 is equal to the length of negative R. So 5 times the sine of 50 degrees is equal to my positive U, because so is the opposite of the angle and ka is the adjacent. So sine would be the U term. So let's find the U term on our calculator. 50 sine times 5, 3.83. 3.83 is equal to U. So there's my rectangular coordinates for this polar coordinate that we've been given. We have a negative 3.21 R plus 3.83 U. And that is correct. So now let's look at the last one here. And this is very similar to this one. It's negative 230, and this one is negative 250. So we really just need to go another 20 degrees this way, right, to get almost there. So that means this is going to be 70 instead of 50. So let's just draw another little system here. I'll make it just a little bit bigger by emphasizing this quadrant that we're going to be in. So negative 90, negative 180. 250 minus 180 is going to be 70. So it's going to be right in here somewhere. All right, so that's going to be a 70-degree angle right there. So we're going to come straight down. This is still negative r, this is still positive u, and this is a 3 length on the hypotenuse. So we're going to do the exact same thing. We're going to take our hypotenuse length times the cosine of the degree of measure, and that's going to equal our negative r value. So that's going to be 70 cosine times 3 equals 1.03. So 1.03 is our negative r. We're going to do 3 times the sine of 70 is our positive u. So let's put that in there. 70 sine times 3 is 2.8, and this will round to 2. So 2.82 is going to be our u value. So that's what we're going to do. We're going to write negative 1.03 r and 2.82 u. And that would be everything you had to do for Monday's lesson. We did that in less than 12 minutes. So now let's look at Tuesday's work, 73 and 74. And we are going to simplify these terms that have radicals, or these fractions that have radicals in the denominator. We don't want to have the radical in the denominator, so we multiply to get rid of it. So this would be 5 plus square root of 3 over 2 times the square root of 3. So we just multiply by the denominator in the numerator and the denominator. And basically what we're doing when we do this, the same value over the same value in a fraction, it's the value of 1. So we're using the identity property here we're not changing the value of this fraction, we're just changing the form. We're just changing what it looks like. And we're just making it easier to think about. So when we do this, 5 times 2, that's going to equal 10 times the square root of 3. And then 3 times the square root of 3 is 3 times 2. That's going to be plus 6. Now, 2 times 2 is 4, and square root of 3 times square root of 3 is 3. So 4 times 3, that's 12. All right, now I see that we can reduce some things here. We can divide everything by 2. And when we do that, I'm going to rewrite this so this is the second term because that's the proper format. So 6 divided by 2 is 3. And 10 divided by 2 is 5. This remains the same. 12 divided by 2 is 6. And that would be the answer to this problem. All right, let's do number 2. We're going to simplify here by conjugating. But before we can do that, let's simplify this term here. We know we can pull square root of 4 times 3 out of here. So that means we can pull a 2 out front. So that's going to be 2 times 2. So we have 4 times the square root of 3 minus 3 times the square root of 3. We can reduce that. We can solve that. Those are like terms. So what we actually have for this numerator term is just square root of 3. It's 1 times the square root of 3. So on the bottom, we still have 2 times the square root of 3 minus 3 times the square root of 2. And that's because they're not like terms. But now we can conjugate this and say 2 times the square root of 3 plus 3 times the square root of 2 over 2 times the square root of 3 plus 3 times the square root of 2. And I don't know about you, but it helps me to put these in parentheses. It just helps me to kind of see it a little bit easier. I guess it's the FOIL method stuck in my head. It's up to you whether you need to do that or not. It still means the same thing with the little time symbol. I just see the order better. It's just a me thing. So do what you need to do to get that. So that's going to be square root of 3 times square root of 3 is going to be 3 times 2, so 6, plus 3 times the square root of 6. And then one of the things that we know, if you notice there's a pattern, whenever you have the inner and the outer multiplied times each other with conjugation, those terms cancel each other out because one is going to be negative and one is going to be positive. So you have a negative 3 times square root of 2 times a positive 2 times square root of 3, and then a positive 2 times square root of 3 times a positive 3 times square root of 2. So these are going to cancel each other out. So the only terms that really matter or that really have any kind of an impact is going to be the first and the last. Those are the two that are going to do the calculations, but I'm going to go ahead and show you anyway. This one times this one is going to be 4 times 3, because square root of 3 times square root of 3 is 3. So that's going to be 12. The inner, or this last term, that's going to be a positive 6 times square root of 6. The inner term, okay, so this was the first term, and this was the last term, or outer term, I guess you should say. The inner term, that's the inner term, is negative 3 times square root of 2 times 2 times square root of 3, so negative 6 times square root of 6. And then you have the last term, which is this last one times this last one. It's going to be negative. Then you have negative 3 times positive 3, that's negative 9, and a square root of 2 times square root of 2, that's going to be 2. So negative 9 times 2 is negative 18. Notice how the outer and the inner cancel each other out. So the outer term and the inner term will always be opposites whenever you're conjugating. So technically, you only have to multiply the first terms and the last terms for what's going to go here. And in doing so, you get like terms, which are whole numbers. So 12 minus 18 is going to be a negative 6. Well, we don't like to have a negative in the denominator. So times negative 1 over negative 1 is going to be negative 6 minus 3 times the square root of 6 over positive 6. Now, this can all be reduced. We can divide everything by 3 and get negative 2 minus the square root of 6 over 2. And that would be the answer. All right, let's look at this one. And make note of the FOIL that we do. We're going to skip these two because they cancel each other out. Or you can skip those two because they'll cancel each other out. And we'll prove that as we go through. So here we have a standard 3 times square root of 5. Can't do anything to simplify that any further. 2 minus 2 times square root of 5. It's kind of the same thing. It's simplified as far as it can go. So we can just multiply. 3 plus square root of 5 over 2 minus 2 times square root of 5 times 2 plus 2 times square root of 5 over 2 plus 2 times square root of 5. So again, I'm going to do parentheses because it helps me to see the FOIL method better. It's just the way my brain works. Or the way it has been working here lately. I'll put it like that. I've also done the stacking method before, which is fine. You can do that. And it does work well. However, I have limited space here and I don't want to take it all up. I could rewrite it with the stacking method and it would take up space. I'm just doing this in a way to show you the FOIL method and how it always creates these two terms, the O and the I term, the outer and the inner terms, that cancel each other out every single time. That's why I'm doing it this way, is to give you that shortcut. Because, you know, mathematicians are lazy. I don't think I've ever said that before, but I'm just telling you. All right, so first, 3 times 2 is going to be 6. 3 times 2 times square root of 5 is going to be positive 6 times square root of 5. Square root of 5 times 2 is going to be a positive 2 times the square root of 5. And square root of 5 times 2 times square root of 5 is going to be 10. Because these two would make 5 times 2 is 10. So there is everything from the FOIL, F-O-I-L, from the first two binomials. Here's the second two binomials. You're going to get 2 times 2, that's 4. And then you're going to get 2 times positive 2 times square root of 5. So that's going to be plus 4 times square root of 5. Negative 2 times square root of 5 times 2 is a negative 4 times square root of 5. Negative 2 times positive 2 is negative 4 times square root of 5 times square root of 5 is 5. So negative 4 times 5 is a negative 20. Notice the inner and the outer terms cancel. Always. You can always get rid of those. So now let's combine like terms. So we would have 6 and 10, that's going to be 16. And then we would have 6 plus 2 would be plus 8. Yes, that's right. Hello, I was fixing to erase it. 6 plus 2 is 8 times square root of 5. All right, so I already see a trend going here. 4 minus 20 is negative 16. We're going to do the same thing we did up here, times negative 1 over negative 1. And let's go ahead and reduce this. I'm going to move it over just a little titch. Titch is a technical term. It means just a itty bitty bit. So that's going to give us negative 16 minus 8 times the square root of 5 over positive 16. We divide everything by 8, and that gives us a negative 2 minus the square root of 5 over 2. And that would be your answer. So you can see you can actually skip the outer and the inner term when you use the parenthesis and you multiply them as if they're binomials. Now you can absolutely still do the stacking method. That works, and it works well. But doing it like this, for me, helps me to see the only ones I need to multiply are the first and the last. So this one times this one, and this one times this one, to have terms that actually affect the outcome. So let's look at the last one here, where we have to conjugate. I think this is from lesson 73. Yeah, these are all lesson 73, and number 5 begins lesson 74. So we're going to do basically the same thing. I'm going to move this up just, again, a titch, that little technical term. We're going to move it just right there so I have a little bit of room here. So I can roll this up. There we go. So I don't see anything. Yes, I do. This is 4 times 2, which means 2 times the square root of 2. Well, guess what, folks? 2 times the square root of 2 minus 2 times the square root of 2 equals 0. 0 divided by, it doesn't matter, is equal to 0. That's it. You don't even have to do any math. All you had to do was reduce this one radical, figure out you had a 0 on top, you're done. Hallelujah. Less math. Okay, number 5. And no, it's not the last one. We've got more. All right, so Bernard raced twice as fast as the local domestique. For this reason, he raced 120 miles in 3 hours less than it took the domestique to race 105 miles. Okay, so we've got to complete the table below with their rates and times. So let's think this through. Bernard raced twice as fast as the local domestique. So his rate, that's his speed, is going to be 2 times the rate of domestique. So the rate of Bernard is equal to 2 times the rate of Domestique. I love that name. It sounds so ooh la la French. For this reason, he raced 120 miles in 3 hours less. So we're talking about his time now. He raced 120 miles in 3 hours less than it took Domestique to race 105 miles. So we can draw, let me wrap my head around that for just a second. It's been a quick, hot second since I did these types of problems. I need Miss Anna to help me with these, but okay, I think I got it. Okay, so we're going to draw a little picture that's going to help me. Always draw your little picture. It'll help you solve the problem. So he is racing 120 miles. So his rate, this is Bernard, it's 120 miles. Bernard did 120 miles. And his time was, the time of Bernard is equal to the time of Domestique minus 3 hours. And Domestique did 105 miles. So she did 15 short of what he did. And then her time was whatever her time was. Okay, so I think I can work with that. So let's see. This is what's going to give us our equation. So we have the rate of Bernard times the time of Bernard is equal to 120. And we have the rate of Domestique times the time of Domestique plus 15 is equal to 120, which I guess we could just say is equal to 105, because that would be what that is. All right, so that is some equations to help us solve everything. So now what we're going to do is we're going to use 2 times the rate of Domestique here. And then we're going to use this here. So we have, 2 times the rate of Domestique times the time of Domestique minus 3 is equal to 120. So if I multiply this, I get 2 times the rate of Domestique times the time of Domestique minus 6 times the rate of Domestique equals 120. So I can sub in 105 as the value of RDTD. 2 times 105 minus 6 times the rate of Domestique is equal to 120. So this would be 210 minus 6 times the rate of Domestique equals 120. Subtract 210 from both sides. And this cancels. Negative 6 times the rate of Domestique is equal to negative 90. Is that right? Yeah, that's right. So negative 90. So I can divide both sides by negative 6. And the rate of Domestique is equal to 15, I think. Let's see. 90 divided by 6 is 15. Okay, good. I'm not completely crazy. So the rate of Domestique is 15. All right, now that I know the rate of Domestique, I can find the rate of Bernard, because that's 2 times 15, which equals 30. So the rate of Bernard is 30. Now I can find pretty easily the time of Domestique by putting in her rate. 15 times the time of Domestique is equal to 105. So if I divide both by 15, the time of Domestique is going to be, I don't know, because my brain is all just old. All right, 7. So the time is 7 for Domestique. So that means I can come up here and I can say the time of Bernard is equal to the time of Domestique minus 3. So 7 minus 3 equals 4. So his time was 4. And that should be the correct answer. So sometimes you got to draw that little picture just to wrap your head around what you need to do. And then you can solve. All right, let's look at number 6. Little John rode the 28 miles to Sherwood Forest at a leisurely pace. He stayed too long at Robin's lair and had to double his speed on the way back in order to get home in time. If his total traveling time was 12 hours, how fast did he travel in each direction? So we can assume the 28 miles here is the same distance both ways. So Little John's time there and back, the distance is the same there and back. So the rate there times the time there is equal to 28 miles. That's the distance. And the rate back times the time back is equal to the same distance. His total traveling time, oh wait, I'm ahead of myself. He had to double his speed on the way back. So that means his rate back, his rate on the way back is equal to 2 times his speed or his rate there. If his total traveling time was 12 hours, how fast did he travel in each direction? So his time there plus his time back is equal to 12. Okay. So we can do this. All right. So I am going to drop in, I'm going to use RBTB equals 28. So RB is 2 times RT. And I'm going to multiply that times the value for TB. This is the one I'm using. Let me highlight that. I'm using this. Now, I have to create a substitution value for TB. So I'm going to subtract the time there from both sides. And that's going to give me TB is equal to 12 minus TT. So let's put that in here. 12 minus the time there is equal to 28 because this is the one we're using. So that's going to be 24 times his rate there minus 2 times his rate there, time there, equals 28. So his rate there, time there, is 28. We know that already. So 24, rate there, minus 2 times 28 is 56. So I'm going to go ahead and do that math. I'm not going to make you suffer through another line there. If I add 56 to both sides, I can do that in one step. I don't have to do that separately. So if I add 56 to both sides, I get 24 times the rate there is equal to 8 plus 6 is 14, carry 1. 5 plus 2 is 7, carry 1 is 84. So I'm going to divide 84 by 24 to get the rate there. So the rate there is equal to 84 divided by 24. His rate there is equal to, I'm not doing this in my head, too old for this kind of mess. 84 divided by 24 is 3.5. I'll take it. 3.5 is his rate there. Rate there, 3.5. Okay, now from that, we can just start filling things in. The rate back is 2 times the rate there. 2 times 3.5 equals 7. So his rate back is 7. Well, I can just look at this now, and I know that 7 times 4 is 28, right? The rate back is 7 times 4 is 28, because 28 divided by 7 is 4. So this is 4, which means this is going to be double. So this has got to be 8. So, yeah, his rate there, 3.5 times 8 is equal to 28. We've already just established that through this division over here. So those are the answers, and that is how you would solve in that way. So let's look at one more. Last one, and we have plenty of room down here, so I think I might just, spread it all out. Regina cycled 4 times as fast as her challenger. So Regina's rate is equal to 4 times the rate of her challenger. She's fast. In fact, she cycled 80 miles in 2 hours less than it took her challenger to cycle 30. So her rate, Regina's rate, and Regina's time was equal to 80. The rate of the challenger times the time of the challenger was equal to 30. We got that from she did 80 miles and he did 30 miles. This is the distance, 80 and 30, right? Now let's look at the time. She did hers in 2 hours less. So the time of the time of Regina is equal to the time of her challenger minus 2. Because she did her speed or her distance in 2 hours less than he did his distance. So there is our other substitution value. So we are going to use this one because we have a substitution value for RR and we have a substitution value for TR. So we're going to drop those in. 4RC times TC minus 2 equals 80. 4RC TC minus 8RC is equal to 80. RCTC is 30. 4 times 30 is 120. We're going to subtract 120 from both sides. So that cancels. Negative 8RC is equal to negative 40. Divide both sides by negative 8. The rate of the challenger is 5. So the rate of the challenger was 5. That was the speed. Well, if the rate of the challenger is 5, then 4 times 5 means Regina's rate is 20. That helps me to solve for Regina's time by saying 20 times TR is equal to 80. I'm just going above this. And if I divide both sides by 20, then TR is equal to 4. And if TR is equal to 4, then TC has got to be equal to 6 because I can add 2 to both sides and find this is 6. So 20 times 4 should be 80, and it is. And 5 times 6 should be 30, and it is. So those match up to what their respective answers are supposed to be. And that's all we had for this week. If you have any questions, please feel free to reach out and ask. You've got Wednesday off, so that was awesome. Hopefully you had it off. If you had to struggle through, you might have taken Monday off and then done these Tuesday and Wednesday. That's perfectly fine too. since Monday was technically a holiday. But we did all of these problems in less than 40 minutes. So, and that's even with my rambling and craziness and letting the dog out and all the other stuff. Anyway, if you need help, ask for help, send us a message, and we will respond as soon as possible. And I hope that everybody stays warm, has some hot cocoa somewhere along the way, and gets to spend a little bit more time with your loved ones, given that, you can't get out and about as much as normal. So enjoy the time that you have. Make the most of it. Get your schoolwork done, and then do some fun stuff. And we'll see you next week.